So in this lesson, we're going to look at one-step equations, and I'm going to focus on one-step equations that require just addition or subtraction. I'm going to start by reviewing balance scales, and if you need more details on this, there's a video on this topic already. I'm also going to review opposites of numbers, and some others may call it additive inverses, depends on what country you come from or what country you're watching this from. And we're going to also look at the steps that I like to follow to solve one-step equations, and we're going to walk through some examples together using those steps. A balanced scale just means that you have two sides, and then you have the same quantity on both sides, and this equal to sign right here is that indicator that both sides have the same value or the same quantity. Let's look at opposite of numbers. The opposite of numbers is more of the American approach or the American terminology, and the additive inverse is more of the European, and in some other countries in Africa they use that approach. So the opposite of a number, or the additive inverse, is really a number that you add to an existing number so that the sum of both of them is equal to 0. And that's really the content, that's really the definition of opposite or additive inverse. Now, how do you go about getting this additive inverse or opposite of a number? All you do simply is you change the sign in front of the number, so you use the opposite sign. So for example, in this case, you have -5, the opposite is going to be +5. Here you have 9, which means that you can assume that there's a positive in front of it. So all you have is a negative sign with the same value. If you add these numbers together, you're going to get 0. Now here we have a fraction, -4/5, or -4/5. Now the opposite of that, or the additive inverse, is +4/5. So that's all you're doing. And when we go into solving equations, I'll show you another way to think about it so that it makes more sense to you. So how do we go about solving one-step equations? The first thing we want to do is to identify a variable to isolate. There's going to be a variable that needs to be isolated. When we say the variable to isolate, we're saying just find a variable that needs to exist on its own on one side of the equation. Or if we're looking at the scale, one side of the scale must have a variable, the other side must have a number. And then we want to identify the opposite or additive inverse of the number that needs to be removed to isolate the variable. We will add that to both sides of the equation, and then we will check that our answer is written as variable equal to number. Now let's use this in some examples. So first thing, we have this equation here, x plus 7 equal to 9. Now what we are going to do, I'm going to actually use a scale in this context right here. So let's have a scale. This is going to be our balancer right here. Put it equal to right here. We have x plus 7, and we have 9 on this side. So we have the second step is first step is to identify the variable. The variable is x right here. Now we want to find out how can we isolate x, which means what do we need to do so that x can stand on its own. Now we can use the opposite, but let me show you another way I think about it. So in this case, I'm adding 7 to x. So what do I have to do? The opposite behavior of that is to subtract 7. So I'm going to subtract 7. And so what I want you to think about now is, when I take 7 out of here, guess what happens? The right hand side becomes heavier. So what do I need to do to make sure I keep that balance? I also take 7 out of here. So now, what does my scale look like? I have the same scale equal to right here. So I'm left with, I have 7 here, I take 7 off, so there's no number right here. So I'm left with just x on this side, and then I am left with 2, x equal to 2. So that is the scale approach. Now the approach that is more common for most teachers or most instructors is this approach right here. So I have x plus 7 equal to 9, x plus 7 equal to 9. What I need to do now is find out the opposite of plus 7. That's going to give me minus 7. And because I have a balancer right here, this equal to means they have to be balanced. What I have to do on the left-hand side, I must also do on the right-hand side. You see, they're the same, but this scale approach just try to show you why we make those decisions. So we now have x equal to 2. Let's look at another example together. So in this case, for these examples, I'm going to do a scale approach and the classroom approach, quote unquote. So in this example, I have 2x. So let's draw a scale. I have a scale right here. This is equal to right here. And then I have 2x on this side, and I have x minus 3. In this case, you have the variable to isolate is x, but you have x on both sides. So you have to figure out which of these x variables do I need to isolate to get my final value. So let's look at this. You have x on the left-hand side and x on the right-hand side. So, and we have negative 3 on the right-hand side. Our goal is to isolate the variable on one side and the constant or the number on the other side. So in this case here, I have the number already on the right-hand side. So how about I just go ahead and get this variable out? So let's test our knowledge of opposites. So opposite also applies to variables. So here we can assume that there's a positive x here. So the opposite of that is a negative x. The opposite, and remember, what you're going to do on one side of the scale, you have to do on the other side of the scale because you want to make sure that this equal to still applies. So we subtract x right here. So let's draw a second scale. So we have 2x minus x, we're left with x on this side, and then we're left with negative 3 on this side. So let's go ahead and do it the classroom approach. So 2x equal to x minus 3. And so this x needs to move. So we subtract x from this side, and we also have to subtract it from this side. So 2x minus x, we're left with x. X minus x is 0, so we're left with negative 3. The next question we have is 3x equal to 2x plus 9. So let's go ahead and draw our scale. Got a scale right here, put an equal to right here, and then 3x on the left hand side, 2x plus 9 on the right hand side. Now what we need to do here is isolate x. We have x on both sides, so I'm going to have to remove x from one of the sides and move it over to the other side. So I'm going to pick, because I have a number already on the right hand side and I have a variable with that number, and then on the left hand side I have just a variable, I'm going to move the variable off from the right hand side so I have just a number left. So how are we going to go about that? The variable here is 2x. So I'm going to remove 2x, so I'm going to subtract 2x from that. So I'm going to remove the 2x here, and because I removed the 2x here, I also have to remove a 2x right here. Because remember, we always want to make sure both sides are of equal value. So 3x minus 2x, let's draw another scale. Equal to right here, 3x minus 2x, we're left with x on this side. 2x minus 2x, that is going to give us a 0, and we're left with 9. So now let's go ahead and use the classroom approach. 3x equal to 2x plus 9. So I'm going to subtract 2x from this side, subtract 2x. You can see x equal to 9. And so for the final example, I'm not going to use both approaches. I'm going to just use your classroom approach. I hope that now you've seen the benefit of understanding balancing scales in solving equations. So the final example is x minus 6 equal to negative 3. So I need to isolate x, and there is a number here already. So I'm going to find the additive inverse or the opposite, which is plus 6. Other way to look at it is, in this, on the left hand side, I'm subtracting 6. The opposite behavior is to add 6. And then we do the same right here. So we have x minus 6 plus 6. We're left with x minus 3 plus 6, or we can say 6 minus 3, which is going to give us 3.